So I mentioned CQRS a number of times. So really, what is it? At its core, it's really based upon Bertrand Meyer's command query separation principle, CQS. So you can read that. But in essence, what it really says is that I have two types of operations within my system. One are commands, one are queries. The other one's queries. Commands basically say do something, and I'm going to get an acknowledgement back that that thing basically happened. Queries are going to say, just give me some data, but they don't change the state of your system. So I'm sure we've all run into properties where, you get a property value back and suddenly stuff within your application changes all over the place. You call the property again and other stuff changes. And that really shouldn't be the case. Those getters, really shouldn't affect the overall system. Anything that affects the system should in essence be a command, and that at its core is what CQRS is completely based upon. Everything else, you mix in some domain-driven design. You throw in some event sourcing if you want. You can throw in all sorts of stuff, but at its core, this is what CQRS is all about. It's a very simple principle, but it can become very powerful very quickly. So as I said, CQRS allows you to encapsulate or surround or protect your business logic within your domain. It does allow for scalability, and we'll see in some diagrams in a moment. Allows you to do that pretty easily. It can provide for fast reads if you decide to go that route at the, in quotes, expense of a more expensive write. And really, once that data is read by the client, well, let me get into that in a second here. If you decide to go for that with a fast read at the expense of a more expensive write, I really think your application can really become can really scale very easily and very quickly if you needed to. But what this really implies, though, is that those commands that you're issuing to your back end are essentially asynchronous in nature. That's one way you can handle it, and that's the way that I approached it, is that your commands are handled in an asynchronous nature. But what that means then, though, is that I issue a command to update an order or do something like that. I don't wait for that command to finish. I just kind of keep moving on. So the user's experience is pretty quick. They're not waiting around for something to happen. They're not waiting for a transaction to commit. But then again, you're also you may also have to wait for that data to fully process through your system. And this kind of gets into a concept of eventual consistency. And the thinking is that a system will eventually become consistent with the events that have been fired within it. So as an example, if let me pull up. I can pull up brain credits here real quick just to run through a quick example of kind of what I mean. So let me pull up the site. So hopefully everybody can see this, and if you don't, set your thing to red, and I'll take a look. But this is the site actually that's hosted out in Azure, and so it's live. And so here's our class or our session today that we were talking about. So I created a class out there. Again, this isn't a sales pitch for brain credits. It doesn't generate any revenue, so I'm not getting rich off of it. It's more of a hobby. But it's taught me quite a lot. But here, as soon as I brought this session up, or this lesson up, as we call it in brain credits, this data's already become old. And how do I mean? So the publisher is me. But I may have gone in behind the scenes and changed the title or changed the type. Maybe I retagged it. Maybe a few other people viewed it, so the views increased. Maybe I changed the amount of credits that this session is worth. So really what I'm looking at right now is stale data. Even the credits that this is my user account, and these are the number of credits that I've earned. I don't have any credits yet on my transcript, so to speak. So this whole time, as soon as I brought the data up, it's old. There could be changes that happen behind the scenes in the system, and I'm not aware of it as a user. So there are a couple of ways that I can handle that. One is maybe something that I do on Stack Overflow, and you guys may do too, is when I answer a question, what do? I keep hitting F5 to see did somebody accept my answer, did they upvote it, downvote it, or what. The system doesn't really update. So it's a manual type of update, but eventually my screen is going to be pretty consistent. I'm going to keep hitting F5, and so I could do the same thing here with brain credits. I could keep hitting F5 and seeing if my data updates. I could also handle eventual consistency, maybe in a way that says, well, when I say I'm going to post this lesson to my transcript, and I want to be able to claim credit for it, well, I could post it to my transcript, and maybe I redirect the user to a different page that says, hey, thanks a lot for doing this. Click here to get to another list of lessons or something. So you sort of take a user through maybe another path, or maybe explain to them what's going on, and in the meantime, stuff's happening in the background, and eventually that user sees what's happening. Or you could take the approach of polling. So maybe there's bits of information on the screen you want to update. On Stack Overflow, it'd be great if there was polling that would automatically update my reputation score. It's not the case, but that could be something that says, hey, eventually my reputation score is pretty much consistent with the events that have happened in the system behind the scenes. So with brain credits, let's take the approach of polling, because when I post this transcript, and we'll get into details about what's going on and how this flows through the whole Azure system, when I post this to the transcript, I'm issuing a command. So of course, with CQRS, it's either a command or a query. So this is a command saying, hey, post this to my transcript. I want to add this to my transcript. So I click the post button, and what's going to happen is I'm going to redirect it to a page that says, hey, you've just posted this. But it hasn't fully made its way all the way through the system. All the events haven't been raised. All the events haven't been taken care of. So what I need to do is I need to have some sort of polling mechanism in the system to eventually make my user's experience consistent with what the read model is behind the scenes. So if I click this and you kind of watch the little credit thing up here, hopefully it works. The demo gremlins aren't on high alert. But I click to post this to my transcript. When the page comes up, my credits are 0, but now there's a little poll that's going to happen that says, hey, check the database, see if anything's happened, see if anything's been updated. Hey, this user's just updated something in the back end. Update the UI. So it's very small bits of information going up to the server, to my web role technically, and then my web role sends back any kind of response that may come back. So this kind of allows the system to eventually be consistent. That's one way you can approach it. There's a number of different ways, and there's tons of conversations on the web about this stuff, but that is kind of a key aspect of CQRS, is to be able to understand eventual consistency, design your system with that in mind, and know that that's going to happen, and basically account for it. So then, I click on the session again to get back to it. I can say it's already posted, and I can remove it from my transcript and all that. So that was the quick tour of brain credits and eventual consistency. But the key thing is that eventual consistency is a key aspect within the CQRS system. It's something you really should keep in mind and definitely take advantage of. So again, CQRS really is an architecture where commands and messages going in, possibly asynchronous. You may want to consider that to really take full advantage of the architecture. And then your queries are really just going against the read model. But what this ends up doing is it really flips that conventional wisdom of fast writes and slow reads to a system where my reads are very fast because my data is essentially flattened in the back end, and we'll see how that happens, at the expense of an asynchronous operation that eventually processes my write operation. And what this really means is that CQRS is going to split your application into two parts, the read side and the command side. And we'll see how this directly plays with Azure and how you should probably approach your Azure application or your Azure solution with this in mind. So really the two parts, the read side and the command side. The read side is going to be responsible for all those queries. The command side is going to be responsible for handling all those commands that are being issued. And it really does provide you a very nice separation between the aspects of your application.